Problem solving with 3 sets. Example 4. Question. A sample group of 80 female students were surveyed to find whether they played basketball, camogie or football on a team in school. The data provided is 16 do not play any of these sports, 21 play camogie but not basketball or football, 22 play football, 28 play basketball, 2 play basketball and football but not camogie, 11 play camogie and football, 13 play basketball and camogie. Okay? And then the question is, let X represent the number of students who play all 3 sports. Then the questions that follow, part A, represent the information on a Venn diagram. B, find the value of X. C, what percentage of students play at least 2 of the 3 sports? D, what is the probability that a randomly selected student from the sample plays only basketball? E, what is the probability that a randomly selected student from the sample plays basketball or camogie but not football? F, what is the probability that a randomly selected student from the sample plays basketball and camogie but not football? Okay, so prior knowledge for this question is that A or B means A union B, A and B means A intersection B, and the cardinal number of A union C equals the cardinal number of A plus the cardinal number of C minus the cardinal number of A intersection C. So here we go. So for the Venn diagram, we always start with the intersection of all 3 sets. But this time, however, we have not been given that information. So they have asked us to let X represent the number of people who play all 3 sports. So we're going to put X here in the middle. Okay, so let's look at the data given in the question. 16 do not play any of these sports, so that means they are here on the outside of B union C union F. So there's those 16. Next we have 21 play camogie, but not basketball or football. So or means A or B means A union B. Okay, so 21 play camogie, but not basketball or football B union F. So let's cover up B union F. And you can see the part that we're left with there is the people that play camogie only. So that's our 21 people there. Next piece of information is 22 play football. So there we go. 22 in the whole of that purple circle play football. Next we have 28 play basketball. So 28 in the whole of that circle, the yellow circle, play basketball. Okay, 2 play basketball and football but not camogie. So and means intersection. So 2 are in B intersection F. Okay, so that's this orange piece here, B intersection F, but not camogie. So we have to block out the camogie circle. So those 2 players go here. Okay, next piece of information. 11 play camogie and football. So and means intersection. So that's this indigo part here. 11 people are here. Now you can see we already have X number of students accounted for. But we're told that 11 is the number for the total of this intersection. So this little bit here then is just going to be 11 students minus the X we already have. So what we put in there is 11 minus X. Okay? Right. So on to the next piece of information. We have then 13 people play basketball and camogie. So and means intersection. So B intersection C is this green part. And the same thing again, we already have X students accounted for, but we're told that the total number for the green part here is 13. So that means for this little part here, it's going to be 13 minus those X already accounted for. Okay, so that's a little bit difficult. You just have to practice with that. Okay, so part B, find the value of X. So what we have here is prior knowledge that's important for this example. So there are three ways to find the cardinal number of A union B. So we can do it just the regular way, the cardinal number of A union B by reading it, or we can look at the cardinal number of A plus the cardinal number of B and subtract the cardinal number of A intersection B, or we can look at the cardinal number of the full universal set and take away the cardinal number of A union B complement. So all the elements that are not in A union B, take those away from the universal set. Now it's a payoff against these three that you can use for problem solving to find something like the value of x in this question. Now the one that we're going to focus on is B union F, the yellow and the purple circle. The reason why we're doing that is because the yellow and purple circle contain all my information on x. Okay, they can contain the 13 minus x, the x, and the 11 minus x. So we're going to focus on B union F. Okay, so one of the ways to find B union F is this last one here where we focus on the universal set. So we could say that it's the universal set, take away the cardinal number of B union F complement. So here that would be the 80, okay, in the universal set, take away this 21 that isn't in B union F and take away this 16 that isn't in B union F. And what we get there is 43. So that's one answer for B union F. Now we're going to look at it in a different way. We're going to look at it by looking at the cardinal number of B plus the cardinal number of F, take away the cardinal number of B intersection F. So we can see over here that the number of elements in B, cardinal number of B is 28, cardinal number of F is 22, and then the intersection of B and F is this orange bit where we have a 2 and an x. So to put those two together, we can simply say x plus 2. So we have 28 plus 22, subtract the intersection, which is x plus 2. And please remember to put brackets on the x plus 2 so that we treat it as a compound. Okay, that the x and the 2 belong together. So it's minus brackets x plus 2. Okay, to resolve this then, let's add the 28 and the 22. And what we're going to have to do is, we're going to have to make sure to multiply this minus into the compound. So both of these terms are positive. So minus by a positive is a minus, minus by a positive is a minus. So we're using our distributive law there. So be very careful of that. So we have 28 and 22 is 50, and then we've minus x minus 2. So now we can gather the 50 and the minus 2. So 50 minus 2 is 48. So simplifying down to 48 minus x. Okay. So now what we have is two answers for the same thing, B union F. So that means that the 43 must be equal to the 48 minus x. So we're going to put 1 and 2 equal to each other and solve. Okay, so 43 equals 48 minus x. Now obviously you can see what number from 48 equals 43. Obviously x is 5. Okay. Using your rules applied to balancing equations, we add x to both sides and we subtract 43 from both sides, and that will get me my x equals 5. Okay, so part C, what percentage of students play at least 2 of the 3 sports? So prior knowledge here is that at least 2 of the 3, this concept in questions, at least 2 of the 3, always is this flower structure in the middle of your 3 sets. Okay, so the petals of my flower, these 3 areas are the people that do at least 2 of the sports. So 2 of the sports, and then in the middle of the flower are the people that do all 3 of the sports. So altogether, this is at least 2 of the 3 sports. So what we're going to do is sub in our x equals 5 that we just found. So 5 will go in everywhere for x, okay? So now we have our numbers 8, 5, 2, and 6. So the number that play at least 2 of the 3 sports are 8 plus 5 plus 2 plus 6 equals 21. And therefore, the percentage that play at least 2 of the 3 sports is 21 over 80. So make your fraction first. Your 80 is your total amount in the set. 21 over 80 multiplied by 100 is 26.25%. Okay, so then part D is, what is the probability that a randomly selected student from the sample plays only basketball? Okay, so the number of students that play basketball only, okay, so we have to focus on the basketball circle, which is the yellow one. We know there's 28 in total, and we already know that we have 8, 5, and 2 students accounted for in this circle. But we don't have this area here. This area is the area where people play basketball only. Okay, these 8 play basketball and camogie. These 5 play all 3 sports. These 2 play basketball and football. These people play only basketball. So we take away the 8, 5 and the 2 away from the 28, and we're left with 13 students play basketball only. Okay, so then the probability of choosing a student that plays only basketball, you have these 13 chances out of the total 80. So 13 out of 80. You can leave your probability as a fraction, or as a decimal, or as a percentage, whichever you prefer. So 16.25% of choosing one of these 13 people. Okay, so part E. What is the probability that a randomly selected student from the sample plays basketball or camogie but not football? Okay, so the number of students that play basketball or camogie. So or means union. Remember that. A or B means A union B. So we're looking at the people in B union C. So here we have it coloured, all the yellow and the blue. B union C, but not football. So we're going to cover up all the people that play football. So what we're left with are these 13, 8 and 21 students. So they are this category. 13 plus 8 plus 21 equals 41 students in this category. Okay, now what we have to find out is the probability. So the probability of choosing a student in B union C less F is 41 out of a possible 80 chances. So 41 out of 80 is the probability, or you can represent that as a decimal, or you can represent that as a percentage, 51.25%. And finally, F, what is the probability that a randomly selected student from the sample plays basketball and camogie but not football? So the number of students that play basketball and camogie, and means intersection. So we will be focusing on B intersection C. So here we have it in the green. Okay, but not football. So let's block out the people that play football. So we're just left with these 8 students here. So what's the probability of picking one of those 8 students? So we've 8 chances out of 80. And we can break that down to 8 out of 80 is 1 out of 10. Or you can represent your probability as a decimal, so 0.1, or as a percentage, 10%. Okay, so that's the end of the question.